Hey friends, Miss Paraso here again, bringing you part 2 of the cheat sheet, okay? All right, so the last one was about angle relationships. This one will wrap us up with the Pythagorean theorem and volume. So I went ahead and got like some things drafted out just to go ahead and get us there a little bit faster. So Pythagorean theorem is a squared plus b squared equals c squared. And what we want to remember is that the A and the B are the legs of the triangle. They form the right angle. They form that 90 degrees. And the C is the hypotenuse or the potential, the longest side. So this here is our C value in this diagram and the A and the B because of where that right angle is. And that's important, so when we're labeling or drawing on our diagram, we know which one is which. Now, the other thing is that, remember, there's the converse. So if we are given 3 side lengths, right, this is the longest side, okay? And so what it's saying is that if we have a potential right triangle, if I said, does 3, 4, and 6, does that equal a right triangle? Well, this side is the biggest side, so if it is a right triangle, that would be our C value, okay? So that means we're going to go ahead and test out the theory. Does it fit the Pythagorean theorem? Does it make a true statement? We get 9 plus 16 is equal to 36. Does 25 equal 36? No. Okay, so while it might make a triangle, it's not going to be a right triangle. It has to fit the rule. Now, if all of a sudden I change that to a 5, okay, the 5 is still the longest side, I would go ahead and plug that in, and now it works, so therefore I can say those ones make a right triangle. Okay, all right, so that might be something that you want to include on your cheat sheet. We also took a look at how we can use the Pythagorean theorem for finding the distance on a coordinate plane. So if we have the actual image drawn, it's actually quite easy. We can simply draw down a vertical line that tells us the distance is between our y values. So in this case, I don't have a grid, but from 8 to -5, well, that's 13 spaces, okay? And then this distance here to form that right angle, well, that's the distance between my x values. So from -2 to 4, that's 6 spaces. And then I can use the Pythagorean theorem and I can go ahead and say, all right, well, 6 squared plus 13 squared is equal to that diagonal squared. And I can go ahead and simplify that expression. And let's see, that's 5, that's 9, that's going to be that. Okay, and then we got to take the square root. And remember, I've told you that if we're going to take the square root of both sides, if it's not a perfect square, just leave it alone for right now. So we can go ahead and get the length of that line. Now, that's the way using the Pythagorean theorem. We also talked about the distance formula, which on the graph right here, I technically did do that. I just didn't show all those steps. So let's take a look at what that would look like in the distance formula. Again, something that might be useful to you to have on your cheat sheet. So what I'm going to do here is I'm going to go ahead and I'm going to label, right? We notice that we have x2 and x1. That just means the x value in one point and the x value in the other point. So good rule of thumb, just pick point. All right, I'm going to say this is x1. So that means it's with y1. x1 and y1 always go together. x2 and y2, they're couple number 2. Okay, and so now I'm just going to go ahead and fill in those values. And the thing that you have to be careful about is this whole idea of minus. So I'm going to do 4 minus, now be careful, it's 4 minus a -2, and we're squaring that. And then we're doing, for our y2 value, we have 8. So we have 8 minus, and again, watch out for that negative. We're subtracting a -5, and we're squaring that. Now, well, what does that end up, right? That's 4 minus 2 versus 4 minus a -2. So we want to go ahead and make sure that we clearly, if we were to simplify that, you could have done that in the first step. You could have jumped right to this. All right, but I do want to let you know that it looks like addition, but I'm really subtracting. Okay. And again, we're trying to find the distance between things. So if you think about it in terms of a number line, right? If we're in the negative realm and then to the positive, that makes sense. So if we just keep on going, we end up getting 4 plus 2 is 6, and 6 squared is 36. And 8 plus 5 is 13, and 13 squared is 169. So you can start seeing some similarities here. I should have put this, let's just squeeze this in here to show that baby step there. Okay, you can see some similarities to what we did over here when we were on the coordinate plane to the Pythagorean theorem. The distance formula is just the Pythagorean theorem, all smooshed up into one step. Okay, the biggest things that to watch out for the distance formula are that subtracting and negative, just watch out for that, and then not dropping your square root. Okay. The other things to think about with Pythagorean theorem, remember you might want to talk about perimeter. Perimeter means the distance around a shape, right? Maybe it's only asking you for what's this length right here, or maybe it's asking you what was the total distance traveled. So those are other clue words that you might want to include. All right, and then our last section, we talked about volume. Now, you're getting all of these formulas. You'll get the Pythagorean theorem, you'll get the distance formula, and you'll have all the formulas for the volume of your shapes, okay? So you don't have to put those on there, but you might want to include them, right? So here we have a cylinder, so that's pi r squared times height, if we label that. And I went ahead and drew a couple circles here just to reference that, hey, the radius is from the center out, diameter is all the way across. You might want to write a note that the diameter is equal to 2 times the radius. Okay, whatever, if that's something that you need, please include that on there. Right, the height of the cylinder is the distance between those two circles. The height here, look here, we have the cone, and that volume was 1/3 pi r squared times height. Again, notice it's the same as the cylinder, just has the 1/3. And so that's the other thing, is that we want to remember that there's 3 cones equals 1 cylinder if they have the same dimensions. So same dimensions. All right, that's a good reminder for yourself that we watched that video where they were pouring the water in, and if they had the same base area and stuff, we wanted to go from there, okay? And then our last one was a sphere. Now, remember the thing to watch out for this one is that it was a little bit different. We had this 4/3 versus 1/3. Again, you will have the formula, but I'm letting you know, I've seen this mistake happen, is that be careful when you're writing it down. It's pi and r cubed, okay? So watch out for those little differences. You might want to highlight that to yourself, okay? And then things we did this with, just identifying what the shape is, identifying the height, what's the radius, how do we find the volume? And you might also want to do something along the lines and maybe give yourself an example. How do I work backwards to find the radius? How do I work backwards to find the height? And those kind of things. Okay. The other thing that we talked about too was an answer in terms of pi. Okay. All right. That means that don't touch pi. Don't touch the pi key. Don't touch your pi. It's dessert. All right. So answer in terms of pi, let's say that you're doing the math and you get I don't know, let's just say for easy math here, you get 10 pi. That is your answer in terms of pi. Throw some units on it, call it a day. If it wants it rounded, right, rounded, and then to the nearest whatever, to the ... right, then you're going to go ahead and you'll hit the pi key, 3.14159 ... and you'll round to whatever value and you'll put on the units. Notice, if it's answering in terms of pi, we have pi in our answer. If we're rounding, then we don't have pi. We have hit the pi key. So that might be another feature that you want to put on your cheat sheet there. And again, if I were you, I might even throw on an example from our notes, especially with the ones like if you have a hard time with working backwards, maybe taking a look at the step-by-step directions on what we did if we had it in terms of pi there. So what I'm talking about here is, let's say, all right, there's a cone and its volume. I'm totally making stuff up here, and I hope it works out. Let's say it's 36 pi, okay? And we want to know what's the height. Actually, let's do this. What's the radius if the height is 12? Now, I have no idea if this is going to work out, so this might not be pretty. All right, well, I've got the cone. I have the volume, so I'm going to start with my formula, 1/3 pi r squared times height. The question was, what's the radius? I'm going to fill in what I know. The volume, I'm going to replace V with 36 pi. Now, notice, right, we have the option. We can go ahead and hit the pi key, but remember, if there's pi in there, just leave it alone. 1/3 times pi. We don't know the radius, and we know that the height is 12, okay? So we did that, and we might say, you know what, let's go ahead and do 1/3 times 12 right now. Let's simplify that. 36 pi is equal to 1/3 of 12 is 4. Okay? And if I'm trying to get that r by itself, that means that I have to divide. And I can go ahead and divide by this. I can take this as a package deal, this 4 pi here. Okay? And that's why I don't like touching the pi key. If my volume has pi in it, I'm going to go ahead and just keep everything as is. And that's going to cancel out. And we get 9 equals, that cancels out over there. Oh, look at that. I made it work out beautifully. And then the opposite of taking the square root, of squaring a number, is taking the square root. So we get that the radius is precisely 9, and we just put units on there. Now remember, units is a measurement, a single dimension, right? If you do units squared, you're telling me that it's area. And if you do units cubed, it's volume. Okay, so please be mindful of what you write for your units. If you're asked for volume, it should be units cubed. If you're asked for the radius or the height or the diameter or what have you, you need to just put the units on it, whether it's centimeters, inches, or just units itself. So hopefully this gave you an idea of kind of how to summarize everything we've talked about. As always, go back into all of the stuff that we did for practice. Take a look at the work, redo some of the problems, check your answers, and hopefully this will help you out.